Good morning, guys. Anjani Kumar here, dealing instrumentation subject for final year electrical students. In the last session, we discussed about advantages of a transducer and basic categories. What are the different types of a transducer that we discussed? I just want to brief remind all the things that what we completed in the last session. Right? We discussed about the advantages of a transducer. So till now we discussed about what is a transducer, right? What is the need of a transducer, right? After that, what are the parts in a transducer, and different examples. All the sensors we can call it as a transducers, but all the transducer may not be a sensor because the transduction element itself, it can do both the sensor and transduction process. So but better example for this is a thermocouple. That is one most important statement from last sessions, right? And after that, characteristics of a transducer. There are different types of characteristics, static and dynamic characteristics. We explained, we discussed in detail each and every characteristics. Right? In an examination, the examiner won't ask about all the characteristics. You just need to write at least 3 or 4 characteristics. That's it, right? So better you just have a brief idea on the characteristics itself is enough. And after that, we started a choice of selection, right? Okay, each and every transducer that it has all the characteristics, no doubt about that. But in that, which transducer that we are going to select for your operation, right? Your operation is whatever the operation. If you want to find the temperature, if you want to find the flow rate, if you want to find the strain, these are non-electrical quantity. So what type of transducer that you are going to choose, choice, or there will be a selection factor. Right? So there will be a selection factor that we discussed all the selection factor in detail. After that, we started advantages of a transducer. Right? So what are the advantages of a transducer? That means signal, the electrical signal. So nowadays we are using electrical transducer itself. Why? Because non-electrical quantity that can be converted to electrical quantity. So because these electrical quantity which may be used for all the instruments, in order to operate the instrument, we require electrical supply. All the computer systems, right? The power supply must be depends on electrical. So that's why we are converting non-electrical quantity into electrical quantity. So we call it as an electrical transducer or electrical sensor, right? The signal which can be easily amplified and attenuated, that we discussed. And after that, mass inertia ratio is less effective. This is the thing that we discussed in a last session, right? Mass, because there is no mechanical moments, there is no mechanical parts. That's why the mass to inertia ratio, we don't have that much effect. And after that, friction is very less, and so we can store that electrical signal by digital techniques, right? So we can store the type of electrical signals that are coming out from the transducer. So we can store that data with the help of some digital techniques. So whatever the sensors that we are using in a transducer, that can be operated by the through a wireless communication system, right? A remote operation, right? After that, we can transfer these electrical signals that coming out from the transducer for a long distance. Right? So these are the advantages that we discussed in the last session. Right? I hope it's clear. It's very, very important question. The characteristics of a transducer and choice of selection of a transducer and advantages of a transducer. In the 3, the definition of a transducer, parts in a transducer, these are very, very important. This is one type of syllabus. After that we'll go for a different types, right? In the last session we discussed about briefly different types of a transducer, right? There are 4 types of a transducer. First one is a active and passive transducer, and the second one is primary secondary transducer, and the third one is analog and digital transducer, and the fourth one is transducer and inverse transducer. So what are the types that we discussed in the last session? Active and passive transducer, primary and secondary transducer, and analog and digital transducer and inverse transducer. These are the basic categories that we are having in a transducer concept. So what is active? But this is only the syllabus that we have, only active and passive transducer. We don't have that much syllabus on primary, secondary, analog, digital transducer and what is transducer. So only the syllabus is active and passive transducer. Right? In the last session we discussed briefly what is active, what is passive, what is primary, what is secondary, what is analog, what is digital, what is a transducer, what is inverse transducer, that all these things. That I just want to remind, that's it. That what type of the type of lecturing is from my side is each and every day I just want to rewind last session for at least 5 to 10 minutes. Right? So better if the new people enter to watch the videos, you just have a brief glimpse of what the last session had. Right? So that's why it will be very helpful for you guys. I hope each and every students following my videos, I thought, but I don't know. But definitely it's your duty to follow each and every faculty videos. You don't know how each and every faculty facing lots of troubles while providing these type of videos for you guys. So it's better at least see once the video what he thought and what he's going to teach, right? All these things, right? So it's my suggestion for your end examination or for your gate oriented or for your IES oriented, you just have a brief idea on the subject, so it will be helpful for you, right? So what is an active and passive transducer? So what is an active transducer? So these are the transducer that doesn't require external electrical supply, right? It doesn't require external electrical supply. So whatever the voltage that coming out from the transducer, that is enough to operate this active transducer, right? So what is that examples? Thermocouple and piezoelectric transducer. Thermocouple, two dissimilar metals joined together, right? Temperature variations, right? Heat will be generated. This heat is converted to electrical energy. So here we don't have any electrical supply to operate that transducer, right? So piezoelectric is very, very important. We discussed following sessions. I don't want to explain here. And what is a passive transducer? Passive transducer or a transducer, for its operation, it requires external electrical supply. That means auxiliary source of electrical supply which is needed for this type of passive transducer, right? What are the passive transducer? The components are RLC. Passive elements are RLC, na? So what are the strain gauge, displacement, length calculations, temperature calculations, all these are presented in the passive transducer. After that, primary secondary transducer. What is a primary transducer? Primary transducer means in single step you will get the result, right? In single step, whatever the non-electrical quantity which is converted to electrical quantity, so in a single step, so that type of transducer we can call it as a primary transducer. I explained about Bourdon tube. Bourdon tube, when a pressure applied, if directly you get the reading, so that is a primary transducer. Or else whatever the output that coming out from the Bourdon tube, it will be given to the potentiometer. With that you will calculate the voltage means. So Bourdon tube act as a primary transducer, and potentiometer or LVDT which are act as a secondary transducer. Secondary transducer means directly you won't get. So from second step, right, at the second stage you will get your electrical quantity from non-electrical quantity, right? So that is about primary and secondary transducer, analog and digital transducer. So what is analog digital whatever the output that coming out from the transducer, the electrical signal which is in analog form. That means it can be operated analog circuits, whatever the inverter converter circuits, these are required these type of electrical signals. So that's why we are generating analog signals at the output of a transducer. And after that digital, so in a pulse form, so sawtooth form, pulse form, these type of result that we get. So the transducer means it converts non-electrical quantity into electrical quantity is called as a transducer. And what is inverse transducer? We require these type of transducer in our power system security, power system operation itself. Why? Because there will be a chance of conversion of electrical quantity into non-electrical quantity also. So in this step we require these type of inverse transducer. So we don't have that much syllabus among these three. We have a syllabus on active and passive transducer. Now I'm going to start about passive transducer. First we'll discuss about passive transducer. What are the different types of passive transducer? What is the operation, principle, and with an example I would like to explain. Right. So what is a passive transducer? I already explained. So this is a session that we are going to start. The thing that what I explained all the previous session, right? So if any problems, any doubts regarding our sessions, you just go through my previous sessions and watch the video. Definitely you'll get clear understand, right? So what is a passive transducer? So I already explained what is a passive transducer. These are the transducers that require external electrical supply for its operation, right? This is the basic definition of a passive transducer. So it requires external electrical supply for its operation. But actually what is a passive transducer means, if you want to find out your non-electrical quantity by changing the physical components of the system. So what are the physical components of the system? There will be a passive components. There is rho LC. By changing the physical components of the system, you will get your non-electrical quantity into electrical quantity. So what are the physical components? Resistive, inductive, capacitive. So that is a basic definition of a passive transducer. So passive transducer or a transducer which can find the non-electrical quantity into electrical quantity by changing the physical parameters of a system. It can convert non-electrical quantity into electrical quantity by changing the physical components. So what are the physical components? Or LC, because the passive elements that are nothing but resistance, inductance, capacitance. By changing this resistance or inductance or capacitance, you will convert the non-electrical quantity into electrical quantity. Right? So there are three types of passive transducers. The first one is because if it is a change in resistance, if you want to find out the temperature, you won't directly find the temperature itself. So temperature can be found by changing the resistance. So with that you can convert the temperature into electrical energy. I'll explain, right? So there are three types of passive transducer. A resistive transducer. Here what is the changing parameter? The resistance is a changing parameters. And the second one is inductive transducer, right? And the third one is capacitive transducer, right? So what is a basic definition of a passive transducer? That requires external electrical supply. Each and every person should tell that definition. But actually, if you find a non-electrical quantity into electrical quantity by changing the physical components, what are the physical components in a passive transducer? So those are physical components are resistance, inductance, capacitance. Right? If you find a non-electrical quantity into electrical quantity by changing the resistance, so that is a resistance transducer. By changing the inductance, that we can call it as an inductive transducer. By changing the capacitance, that we can call it as a capacitive transducer. So this is three are more important concepts. We'll discuss the definition, operation, and with neat examples. Right? I'll explain each and every transducer in detail. Right? No doubt about that. Now we'll discuss about resistive transducer. Right? You will tell the definition of resistive transducer. So what is a resistive transducer? So we can find the non-electrical quantity into electrical quantity with the help of changing resistance in the system. Right? With changing resistance in the system. I'll explain. But suppose I have a resistance, right? So how much voltage? But suppose my contact is here, right? My contact is here. So up to now, how much voltage it is? You can easily find out. You can connect your voltmeter here. Right? You can connect your voltmeter here. You can find how much voltage across this resistance, small resistance. Right? Now, I applied some pressure. I don't know the pressure. Pressure is my non-electrical quantity. Right? That I applied. Right? I applied my pressure. So with that, what happened? Your slide wire, which will move downwards, right? Which will move downwards. ఇక్కడికి వచ్చేసింది. Then you have another voltmeter. You just connect this voltmeter here and you can find the voltage here. So that means ఈ voltage ఇక్కడ ఉన్నది ఇక్కడికి వచ్చింది. So that how much voltage ఇది ఎందువల్ల వచ్చింది? By maintaining your strain pressure. So the pressure, which is a non-electrical quantity, which is equal to the change in voltage. Na? I clearly explain one more time. For a simple understand what I am explaining, right? My slide wire is here. So up to now, what is the voltage? You will find out, right? So this is a resistance of 10 kilo ohm, right? Now your non-electrical quantity is pressure, right? Right? You are applying pressure. So pressure is my non-electrical quantity. So we don't have a direct connection, direct measurement of pressure devices. Right? Nowadays developed, but in olden days we don't have a direct measurement of power, pressure. So what happened? If a pressure applied on this device, how your slide wire will act? Slide wire will move downwards. For suppose if the slide wire is right here. That means you are getting a changing resistance, right? You are finding your non-electrical quantity, which is a pressure. So what happened? The changing resistance will be happen. Okay, how much pressure? ఈ pressure ని అప్లై చేయడం వలన నా స్లైడ్ వైర్ ఎక్కడ జరిగింది? ఈ పాయింట్కి జరిగింది. So this is a 9 kilo ohm, right? There is a change in resistance now. Now you are applied a voltmeter here, right? You can find the how much voltage it is, right? ఈ voltage దేని వలన వచ్చింది? By applying a pressure. So that means whatever the pressure that applied is equal to this much voltage. Got it now? Whatever the pressure that applied is equal to this voltage, right? Equal to the change voltage. I hope it's clear. Whatever the pressure you applied, that is equal to this much voltage. Apply చేయకముందు this much voltage ఉంది. Apply చేసిన తర్వాత we are getting this much voltage, right? So ఇందువల్ల ఈ voltage వచ్చింది, you are applying this pressure. So that my pressure which is analogous to voltage, right? That you are converting non-electrical quantity into electrical quantity. That means here what is non-electrical quantity? The pressure. So what is electrical quantity? The voltage across the changing resistance. How you get that electrical quantity? By changing the resistance. So this is a resistive transducer, right? I hope it's clear. So what is a resistive transducer? So we can find the non-electrical quantity into electrical quantity by changing the resistance. So that is very, very important. Right? That is about resistive transducer. Now we'll discuss. You know that. I'll clearly explain with the examples. So don't bother about this one. Right? You know the formula for resistance. R is equal to rho L by A. Right? So rho is nothing but resistivity, L is nothing but length, A is nothing but cross sectional area, right? That means you will get your changing resistance by changing the length na, so that we can call it as a displacement na. You can easily find the displacement into voltage na, right? If you changing length, that is nothing but displacement, you will get the changing resistance. If you get the changing resistance, you can convert it into voltage by putting a voltmeter, right? So that means the linear displacement, which is a non-electrical quantity, how much displacement moved on the system, converted to voltage. Got it now? This is one type of a transducer. If you apply a resistivity means some sort of force or some sort of thing that you applied. Means if you apply resistivity also, the resistance will change now. If the resistance will change, the resistivity, that is non-electrical quantity. So we don't have a separate instruments to find this type of resistivity itself, right? Right? If you change the resistance, the change in resistance. If you change the resistivity, the change in resistance will be happen now. You can easily find the change in resistance. Whatever the change in resistance is equal to the applied resistivity. So that means my resistivity is a non-electrical quantity, and the resistance and the electric and the voltage that coming out from the transducer, which is electrical quantity. So this type of transducer we can call it as a resistive transducer. That is a displacement transducer. If you have a cross-sectional area, so it is we don't have any direct measurement of cross-sectional area. If you change the cross-sectional area, your resistance will be changed. So with that we can easily find out the change in voltage. So whatever the cross-sectional area is equal to the voltage changing resistance. So that is nothing but change in voltage. So these are the three parameters. From that you can easily find the non-electrical quantity into electrical quantity. I hope it's clear. The first thing is change in length or displacement. So we'll get changing resistance na, right? You will get the change in resistance, that is nothing but a transducer na. You can change resistance change అయిందంటే voltmeter పెట్టి you can find the voltage. ఆ voltage ఎందువల్ల వచ్చింది? You are changing the displacement. So that displacement is equal to that voltage na. That means my non-electrical quantity which is converted to electrical quantity. That's it. right? So this is length is a non-electrical quantity, so we can easily find out the non-electrical quantity, right? So resistivity, change in resistivity, so there must be a change in resistance now. So if the change in resistance happen, you can easily find out the voltage, that means electrical quantity. So the resistivity is a non-electrical quantity. Whatever the voltage you are getting change in resistance, that is electrical quantity. So that is a resistive transducer, right? And the third one is change in cross-sectional area, right? If you change the cross-sectional area, the resistance will change now. If the resistance change, you can directly put voltmeter across the change in resistance. You will find out the voltage now. Now, what is a non-electrical quantity? Cross-sectional area. What is electrical quantity? Voltage. So this is a cross-sectional area transducer. You don't have a direct measurement to find these type of non-electrical quantity like a displacement, potentiometer, and all these things, right? So this is a basic thing present in a resistive transducer. Now we'll discuss about few examples. With that you can clearly understand. So what is a resistive transducer and all these things, right? Now first I'll go for a potentiometer. So potentiometer is a resistive transducer, right? Same that what I explained. The first one is potentiometer, right? Now what is a potentiometer? Similarly that what I explained, potentio is nothing but variable resistance, right? So potentiometer, which is used to find the displacement into electrical energy, so whatever it may be, right? Electrical quantity, that means non-electrical quantity is a displacement, electrical quantity you can find. Now this, you know the potentiometer which is having a sliding wire, right? Sliding wire, right? So one knob is there, or else you can move the knob, or the sliding position is there. So with that position you can vary your resistance, right? At the starting, the first position 1, alright, or you'll get the voltmeter here, right? At position 1, at the displacement is 0 position, so you will get how much voltage present in the system. Now you are moving your position, right? Now the position is here, right? The displacement for B 1 centimeters, right? 1 centimeters displacement is present in the system. So how you can calculate how much distance means? When you are moving the sliding contact means your resistance also vary now. So here the resistance will vary now. So now you will find out the voltage here. How you will get the voltage? That means by varying, by moving the sliding from 0 position to some other position, your voltage will be vary. Ee voltage enduku ochindi? By moving this one, that means whatever the length, what is the displacement which is equal to the voltage developed across the changing resistance na? So that is called a potentiometric transducer. That means whatever the linear displacement which is converted to voltage, right? You don't have any methods, you don't have any measure. So how much distance that is developed, how much distance ni move chesavu, we don't have any measurement, right? So how much distance, how much displacement happened means that much voltage is developed. That means whatever my displacement is equal to the voltage developed. So this is like a potentiometric transducer. I hope it's clear. At 0 position, now we are from the 0 position, you are moving your slide wire, right? That means a linear displacement that is equal to the change in resistance. If the change in resistance happen, you can easily direct that, convert into voltage. Whatever the my displacement which is equal to the voltage that applied, that means non-electrical quantity which is converted to electrical quantity. That's it. And one more thing is there, you know about Wheatstone bridge, second Wheatstone bridge. It is also, that means if this potentiometer, if you want to operate this potentiometer, you require external power supply. So that's why we can call it as a passive transducer. Right? If you go for Wheatstone bridge, right? Right? This is nothing but galvanometric bridge. Right? Right, this is nothing but Wheatstone bridge. This is also passive transducer. So bridge balance, this will give a zero deflection when R1 opposite terms R1 R3 is equal to R2 R4. Under this condition, the bridge will get balanced. Right? See, this is also passive transducer. That means the Wheatstone bridge that can be operated with the help of external supply. So that's why this is called as a passive transducer. Right? Now what I am doing means, now I am changing the temperature here. నేను ఏం చేస్తున్నాను, ఇక్కడ టెంపరేచర్ని ఇంక్రీజ్ చేస్తున్నా, రైట్, అట్ దిస్ R1 పాయింట్. రైట్, టెంపరేచర్ ఇంక్రీజ్ చేసినప్పుడు ద రెసిస్టెన్స్ షుడ్ బి వేరీనా, రైట్. సో టెంపరేచర్ వేరీ చేస్తున్నప్పుడు టెంపరేచర్ని వేరీ చేస్తున్నా. ఐ వాంట్ టు ఫైండ్ హౌ మచ్ టెంపరేచర్ ఈజ్ వేరీడ్. రైట్, ఆ టెంపరేచర్ని నేను ఇక్కడ R1 దగ్గర అప్లై చేశాను. సో వెన్ ఎవర్ ద టెంపరేచర్ వేరీస్, ద రెసిస్టెన్స్ R1 వేరీనా. సో దిస్ కండిషన్ వోంట్ సాటిస్ఫైడ్ R1 R3 నాట్ ఈక్వల్ టు R2 R4 బికాస్ యు ఆర్ వేరీయింగ్ యువర్ R1. రైట్, టెంపరేచర్ నుంచి R1 వేరీ చేస్తున్నా. You will get the galvanometer deflection 0? Definitely not. You will get the 2 volts of a galvanometer deflection. That means how you get the 2 volts? By changing the temperature. This temperature must be equal to 2 volts now. So how much temperature that you are applied at R1, that must be equal to the galvanometer deflection now. Got it now? Right? So whatever the non-electrical quantity, which is a non-electrical quantity? Temperature. What is the electrical quantity? The galvanometer deflection. So that my temperature which is equal to the electrical quantity. So temperature is a non-electrical quantity. So you are getting electrical quantity. So my temperature which is equal to the 2 volts. That's it. Analogous to 2 volts. That's it. We just convert, and that temperature converted to electrical, that can be used for this, right? That's it. So this is about a Wheatstone bridge transducer, and this is about a potentiometer bridge transducer. Right, and one more transducer is there, very very important to find the temperature, RTD. So we can call it as a resistive thermometer. Very very important concept. Definitely will directly explain, will get your end exams, like you just explain what is RTD, what is how the resistive transducer used to find the temperature. Nothing is there, but the same thing happened, right? Whenever there is some metal is there, with that metal, if you heated that metal, the metal should, the change in resistance will be happening in that meter. The change in resistance will be converted to voltage. So whatever the temperature increases, that is analogous to the voltage that are developed across the changing resistance. That's it. Nothing is there. Each and every passive transducer, that the principle is same. So you can find the non-electrical quantity into electrical quantity by changing the physical components itself. Now we are discussing the resistance. Mean the resistance will be changing. Right, so displacement is for the linear displacement, we'll go for a potentiometer. For a temperature, we'll go for the Wheatstone bridge. You go for RTD, and also different types of strain gauge is there. When you apply a strain, what happened? The length will be increases, right? Due to that length is converted to changing resistance. That is nothing. that we discussed strain gauge. In the concept of strain gauge, LVDT is a linear displacement which is converted to voltage. Some sort of different transducers that are present in the daily life, resistive transducers that are, but we don't want to go for all the transducers. We just need to know what is a resistive transducer and how we can displacement resistivity, a cross-sectional area which is converted to changing resistance. If the changing resistance happen, definitely that can be converted to voltage itself. Right, so these are about a resistive transducer. One more resistive transducer is the resistive temperature detector. So in the next class we discussed about that resistive temperature detector. So with that we'll finish a resistive transducer principle, operation and example and all these things. Right, in the next session RTD. After that we'll go for inductive transducer, capacitive transducer. Alright, so once we finish these two, we have important concepts of LVDT, strain gauge. All these very important. Almost it will take around 10 days to complete this unit, right? And thank you very much.